Hi, my name is Mr. Chu and you're welcome to my study room. What would be your answer if I ask you to write the coordinate of the vertex of the equation y equals x squared minus 4x plus 1 without graphing it? Well, that is the objective for today's study, writing quadratic equations in the vertex form. Let me start by saying that quadratic equation can be written in one standard form, which is y equals ax squared plus bx plus c, where a is the vertical stretch, c is the y-intercept, and you can substitute a, b, and c into the quadratic formula to get the roots or solutions for the equation. The second is factored form, and that is y equals a multiplying x minus m then x minus n, where the solutions or roots are x equals m or x equals n, this and this, but then the signs change because we equated each of them to 0 and solve for x, and that becomes the solution or root for the equation. And then again, a is the vertical stretch or compression depending on the value of a. It becomes a vertical stretch when the a is greater than 1 and a compression when a is between 0 and 1. And for more about vertical stretch or compression, I recommend that you watch my video on transformation of quadratic functions, and I'm sharing the link now, and you can also find it in the description of this video. And let me quickly add that this second form, which is the factored form, is easily obtained when the trinomial is factorable, meaning that when the equation in the standard form can be factored, then we use this. And then again, more about the factored form of a quadratic equation can be considered in another lesson. So let's move on to the third form, which is the vertex form and the focus of our lesson for today. And that is y equals a multiplying x minus h all squared plus k, where h and k are the coordinates of the vertex, and x equal to h is the equation of the line of symmetry. Again, a is the vertical stretch, just as we've known it in the previous two, and for each of them the graph is reflected when the a is negative, meaning the parabola faces downwards when a is negative. And just as I said, the factored form is easier when the trinomial is factorable. The vertex form is also easier when the middle term of the trinomial is even or the trinomial does not factor. Then you can consider expressing it in the vertex form. And this vertex form is also used to describe the transformations of the parent function f of x equals x squared, which I explained very well in the video I mentioned earlier, the link of which can be found in the description of this video. Now let's get back to the original question, y equals x squared minus 4x plus 1. Let's go find the vertex of this equation. To find the coordinate of the vertex of this equation, we are going to use what we call the completing of squares. So we are going to complete the squares, or in other words, we are going to make this expression here a perfect square. And by that, we end up expressing it in the vertex form. Then we pick the h and the k as the vertex of our equation. So let's find that quickly. We first do that by moving the constant term to the left side to join the y, and that gives us y minus 1, because when the positive y comes to the left side of the equal to sign, it becomes negative, equals x squared minus 4x. And then to complete the square, we are going to add square of half the b, or the coefficient of x, to both sides. And the coefficient of x here is -4. Remember to pick the number with the sign before it. So -4 divided by 2 is -2. And we are going to add the square of these to both sides of the equation. And that becomes y minus 1 plus 4, because the square of -2 equals 4, equals x squared minus 4x plus 4. Don't forget that these 4 and these 4 are the square of the half b that we added to both sides to give us that. The right side of this equation now becomes a perfect square. And someone may ask, what's a perfect square? A quadratic expression becomes a perfect square when the third term, which is the c, is square of half of the coefficient of the second term. Whenever you check a quadratic equation and you take half of the coefficient of x and you square it and that gives you c, then it means that that quadratic expression is a perfect square. Simplifying the left hand side, we have y plus 3, because -1 plus 4 is 3, equals, since this is a perfect square, now we express it as factors, and that will be x minus 2 all squared. And someone may ask, how did I get that? It's just x and then the half of b that we got together, and that's -2, so x minus 2, then we square it. When you expand this, we get the trinomial back. So this is the factored form, or the factorized form of the trinomial here. Then the next thing we do will be to move these 3 back to the right hand side, and that gives us y equals x minus 2 all squared minus 3, because we are subtracting 3 from both sides. And this becomes the equation expressed in the vertex form. So now the coordinate of the vertex of our equation is now 2, -3. So it's h and k. So 2, -3. And let me add quickly that the equation of the line of symmetry is x equals x coordinate of the vertex, which is 2. And no one asks of the vertical stretch, but the vertical stretch will be 1 in this case, because when the number is not seen, then it's 1, or the coefficient is not seen, then it's 1. So the coordinate of the vertex of this equation here is 2, -3, and the equation of the line of symmetry is x equals 2. Let's take another example to see if we can solidify what we are learning. Again, we have to find the coordinate of the vertex of the equation y equal to x squared plus 2x plus 5. So we start just the way we started with the question 1. We move the constant term, which is the c, to the left hand side to join the y, and that gives us y minus 5 equals x squared plus 2x. Then we take half of the b, which is the coefficient of x, and that will be 2 divided by 2, and that is 1. After that, we square the 1 and add it to both sides of the equation, and that will become y minus 5 plus 1 equals x squared plus 2x plus 1. And simplifying the left hand side, we are going to have y minus 4 equals, the right side is now a perfect square because square of half of 2 is 1. So that becomes x and then this, so plus 1 all squared. That means we factorize it. Then now we move the 4 to the right side, which gives us y equals x plus 1 all squared plus 4, because the -4 comes to the right side becomes a positive. And again, this becomes the equation expressed in the vertex form, and the coordinates of the vertex will be -1 and 4. Remember, we always switch the sign of what is in the parentheses. And the equation of the line of symmetry, which is also called axis of symmetry, is x equals -1 Let's take another one which looks a bit different, and that will be question 3. Right, in question 3, we are solving for the coordinates of the vertex of the equation y equals 2x squared plus 8x plus 15. And we start just the way we start. And again, I said these look a bit different because now the a is not 1. The coefficient of the x squared is not 1. So we'll do something that is a bit different from what we did in the first and the second one. Let's start by first moving the constant term to the left side, and that gives us y minus 15 equals 2x squared plus 8x. And before we go ahead to divide this, we have to factor the a out. So whenever the a is not 1, we need to factor the a out before we start solving. And that will give us y minus 15 equals a factored out. 2x squared divided by the 2 will give us x squared. Then plus 8x divided by 2 will give us 4x. We now get our own third term to make this a perfect square. So let me leave the space here to show that we'll put a third term there to make it a perfect square. It's like we did for the examples 1 and 2. We take the coefficient of the second term, which is 4, divided by 2 and square our answer, and the answer is 2, so 2 squared. After squaring the 2, we add it here, and then after that we use these 2 to multiply the 4 before adding to the left side, and that now becomes y minus 15 plus 8, which is a 2 times 4, and then that gives us 2 parentheses. You know this is a perfect square, so to factorize gives us x plus what is in the parentheses, so 2 all squared. And then now we simplify this and move it to the right hand side to give us our equation in the vertex form, and that becomes y equals 2 multiplying x plus 2 all squared. Then negative 15 plus 8 is negative 7. And when we move negative 7 to the right hand side, it becomes positive 7. And this becomes our original equation in the vertex form. And the coordinate of the vertex becomes negative 2 and 7. And the axis of symmetry or line of symmetry is x equals negative 2, which is just the x coordinate of the vertex. And this time the vertical stretch is 2. So let's not forget that. We can get the vertex, the line of symmetry, and the vertical stretch from the vertex form. Then let's take another example. In example 4, we have to find the coordinate of the vertex of y equals 3x squared plus 18x minus 12 without graphing. And since this example 4 looks just like the example 3 we solved, I would like you to pause the video and try on your own. Alright, I'm sure you got the coordinate of the vertex to be negative 3 and negative 39. If you were able to get that, congratulations. If not, let's all work it together and see. So we start by moving the constant term to the left side, becomes positive. So we have y plus 12 equals 3x squared plus 18x. Then the next thing we do is to factor the a, which is the coefficient of the x squared, out, and that gives us y plus 12 equals 3 factored out. Dividing here by 3 gives us x squared. Dividing here by 3 gives us 6x. Then plus a third term we'll add by ourselves to make it a perfect square, and that is half of 6, which is 6 divided by 2. When we finish that, that will give us 3. We square the 3, and that gives us 9. We put 9 here, and that makes this a perfect square. But then that is not all. We multiply that 9 by the 3 here. We multiply them, and then the answer is added to the left side, and that becomes y plus 12 plus 3 times 9 is 27 equals 3 multiplying this as a perfect square becomes x plus the number we have in the parentheses, and that is 3 all squared. Then we put these two together and move it to the right side, and that gives us y equals 3 multiplying x plus 3 all squared. 12 plus 27 is 39. Move to the right side becomes negative 39, and this is our equation expressed in the vertex form. And the coordinates of the vertex becomes, we change the sign of this or we equate these to 0 and solve. It's the same thing, and that is negative 3, and the y coordinate is negative 39, and the axis of symmetry is x equals negative 3. Then again, this has a vertical stretch, so the vertical stretch is 3, right? Let's take the very last one, which is a bit challenging, and I'll explain to you why I say it's challenging. We have to find the coordinate of the vertex of the equation y equal to 3x squared plus 7x minus 9. And this is the reason why I said it's challenging. Remember when I was explaining the vertex form of quadratic equation, I said that it is easier to use this when the coordinate of x is even or an even number. But we can see from here that this is an odd number, 7. So it will give us a fraction, and some fear to work with fractions, and that makes it a bit more difficult than when it's just even, where we divide to get a whole number. But we'll give it a try. Let's try it and see. We start the way we started in the past, or in the last 4 examples, the way we did. We're just going to follow the same steps. So we start by first moving the negative 9, which is a constant term, to the left side, and that will give us y plus 9 because it was negative at the right hand side, equals, we factor the 3 out to get this divided by 3 is x squared. Then this divided by 3 becomes 7 over 3x. This is where it starts to look ugly already. Plus dash, this is the coefficient of x, which is 7 over 3. And let me make it easy for a half of that to be times 1 over 2. And that will give us 7 over 6. And we are going to add the square of this here. And that gives us 7 squared is 49. And then 6 squared is 36. And now, you know that is not the end. We now multiply that by this, and then we add it to the left side, and that gives us y plus 9. This times 3 will give us plus 49 over 12, because 3 multiplying this can divide the 36, so we don't need to multiply the 49 by the 3, and that is what gives us the 12. And that will be equal to 3 parentheses x plus the half, which give us 7 over 6 all squared. Then we add these together and move it to the right side, so that gives us y equals 3 multiplying x plus 7 over 6 all squared minus, because this is positive, and when we add the two sides, we should get 157 divided by 12. And this is our equation expressed in the vertex form. So the coordinate of the vertex, which looks a bit messy but correct, is negative 7 over 6, comma, negative 157 over 12. And for those of us who want it in decimal, will be approximately negative 1.17, comma, negative 13.08. This is it. And the equation of the axis of symmetry is x equals negative 7/6, and this is the vertical stretch 3. It's always the same as the A. And to always verify whether your answers are correct, it is just up to you to plot these two into any graphing calculator like the Desmos graphing calculator or even GeoGebra, and you see that the two graphs will fall on each other, or the two of them will give you the same graph. So if you do that and you get the same graph, it means that your answer is correct. But if not, then it means you need to look through your process one by one. And this is how to write a quadratic equation in the vertex form. And this helps us to find the vertex of the graph of the equation without necessarily plotting it. I hope this lesson has been of help to you. If yes, then kindly consider subscribing to this channel for more videos like this. Till we meet again in my study room. Bye bye.